Typically, we are interested in calculating the change in the properties of a system as the system undergoes some process, from some initial equilibrium state to a final equilibrium state. During a process, heat and/or work are exchanged between the system and its surroundings, which may or may not change the energy of the system. However, before describing the process, we need to define the system and its initial surroundings. The system we consider here is a gas enclosed in a metal cylinder and sealed from the surroundings by a freely moving massless piston. Because the piston is initially at equilibrium, but can move freely, and is assumed to have zero mass, the pressure in the gas chamber is equal to the pressure in the surroundings, that is, the external pressure. Because the cylinder is made of metal, a good conductor of heat, the temperature in the gas is the same as the temperature in the surroundings. We say that the system is in mechanical equilibrium and in thermal equilibrium. Now, we quickly move the gas piston cylinder assembly from the low temperature surroundings into the higher temperature surroundings, an oven for instance. As a result of this action, a process is initiated because the system is no longer in thermal equilibrium. Again, because the cylinder is made of metal, it allows a transfer of heat from the hot surroundings into the colder system. As the temperature of the gas increases and the pressure of the gas remains the same as that of the surroundings, the volume of the gas must increase. Note that the volume can increase because the piston is freely moving. Had the piston been locked in place, the gas volume would not be able to increase and the gas pressure would have increased. When the temperature of the gas reaches the temperature of the hot surroundings, the transfer of heat from the surrounding into the system ceases, and the gas reaches a new equilibrium state. So the process was initiated by the transfer of heat and resulted in a change in both the temperature and the volume of the system. The fact that the volume of the system changed while being opposed by the external pressure means that work was done. Note also that the process starts with the system existing in one equilibrium state and ends with the system in a different equilibrium state. It is important that you keep in mind that there is no work or heat while the system is in an equilibrium state. Work and heat can only be exchanged and can only have a meaning during the process. In contrast, the energy is a state property. So unlike work and heat, energy, temperature, volume, and pressure are well-defined quantities for the system, both at the beginning of the process, initial state of the system, and at the end of the process, final state of the system. We say that work and heat are not different forms of energy, they are different forms or modes of energy transfer. Heat results from a difference in temperature, while work is associated with some motion against an opposing force. Here, work results from the motion of the piston against the external pressure and the increase in the volume of the gas.